I'm going to turn this on. Okay.
Yeah.
So you can see the waves move. I'm going to turn off the light and you can see it even better. Okay, but I can make these waves stop. And the way I do make these waves stop, let me see if I can. Okay. The way I make these waves stop is by changing it to, okay, can you see it's kind of stopped?
Yeah.
Okay, that's because when the wave goes one wavelength ahead, okay, the light comes on. Okay, in between when it's moving, remember these are the peaks. When the peak is moving in between, the light goes off. When it comes back again to the next wavelength, it comes on. So it looks like it is stopped. It's actually moving.
It's
Does
like
that
a
make sense?
strobe light.
Yeah, it's strobing at the right time. So if this goes forward one wavelength, okay, that will strobe at the right time. When the peak is here, the light comes on. When the peak is here, the light comes on. In between, the light disappears. Okay, so I'm going to turn this off, and you should be able to.
Po-po.
No.
Oh my gosh, so
I
cool.
think it's just
Someone throw a football.
teaching.
Okay, so
I heard that people can go into like epileptic shock if you with the strobe lights. Have you heard that? You know,
It depends on the kind of like
epilepsy.
severity of it. Yeah. Some
I know
people can't, like, see
I have a
these
brother
lights.
who's epileptic, and maybe there are, they don't know anything much about the brain. I mean, even
They just say
Some people can't like I know my uncle has epilepsy. Like he can't even see police lights.
really.
you can't
Yeah.
see what? Police lights?
Yeah, like
Wow.
one time he was driving and he had a seizure while he was driving by an accident because there was a bunch of police cars.
It's really sensitive,
And
though. That's
yeah,
the point of epilepsy.
like his brain doesn't attach at the top,
Right.
so he I don't know
The
gave him
hemisphere.
really bad epilepsy, and that's like he was wicked sensitive to it, so he can't drive now.
Oh, wow.
Oh boy, yeah.
That's sad.
Yeah, they don't know much about epilepsy. They just, it's trial and error. So anyway, so this is a wavelength, okay, and we call these plane waves. Now, what happens when it passes through a gap, right? The waves, they begin to bend, right? Remember we talked about that?
Yeah.
Okay, and that, okay, you can see that. Okay. What is the bending called? Anyone remember?
It's like the ripple.
Starts bending, right? It's called diffraction. Okay, it starts bending. So when I remove this out, okay, it's still, now it's straight. But the moment it passes through a gap, it begins to bend. Okay,
Oh,
and
yeah.
that bending is called diffraction.
Okay.
Okay, and that means the light is going this wave is going in all directions. If the gap is much bigger than the wavelength, then it doesn't bend as much. Okay, you can see it goes straight. There's some bending, but not as pronounced. Okay, so this is if the gap is much larger than the wavelength. Okay, there's not as much diffraction. But if the gap is smaller than the wavelength, all right, then the bending is very pronounced. Okay, and so that's what happens, when sound when it goes through gaps, it bends. So if you're standing on the other side, you can still hear sound that's being played in this room. Okay, whereas light, for example, the wavelength is much smaller than the doorway. Okay, so light, you'll see it goes straight here, and if you're standing here, okay, you won't see the light because the light goes straight. It'll create a shadow here, distinct shadow. Okay, all right, this is one. The second one I'm going to talk about, oh, by the way, can you see the wavelength? If I move it forward, the wavelength gets smaller. If I
Yeah.
move it away, the wavelength stretches out. That's Doppler effect. Can you see the wavelengths get smaller?
Yeah.
and wavelengths get larger. Okay, wavelengths get smaller and larger, right? So that's Doppler effect, right? Let me see this. All right, let's see if I can get circular waves. To get circular waves, I'm going to put this over here, and you should be able to see.
So when this is making waves, what part of it is like the white line? Is that the...
That would be the crest.
Okay.
So what's happening is the waves, I can draw it here, right? If you have ever used a magnifying glass.
Yeah, so there's no trough.
Right, if you have used a magnifying glass, what happens? If, let me see, let's see if I can, right? What happens to the sunlight? The sunlight that comes gets focused, right? Mm-hmm. And it creates a bright spot with a magnifying glass. Now think of water waves, right? They go up, right? These are waves.
Yeah.
Oh, okay.
Right? Can you see this acts like a magnifying glass?
Yeah.
And it creates this. Now if it's straight, it creates this line, right?
Yeah.
That's exactly what it is doing.
Okay.
Okay. In fact, on a swimming pool, you'll see there are so many different kinds of waves.
Yeah.
And you can see all these squiggles on the bottom. You know, that's essentially what the light is doing. So we are doing the same thing. We have created, you know, all these waves. I can create waves, right?
Yeah.
Right. So where it's going up, it magnifies it. It concentrates it. So this is a wavelength. Okay. And if I move it to the right, you can see the wavelengths get smaller.
Yep.
Right? And the wavelengths get larger going away. See that?
Mm-hmm.
The direction is going, the wavelength gets smaller. Okay. Also, if I have two of these, I don't know where I placed the other